for problem 1, we always look for GCF first, so you just treat the coefficients and the variables separately. So from 12 and negative 3, those both have a 3 in them. A squared and A, those both have at least an A. And B squared and B, those have at least a B. Okay, so originally we had 12A squared B squared minus 3AB, but now we are factoring out a 3AB. Okay, so 3AB remains on the outside. On the inside, 12A squared B squared, 12 divided by 3 is 4. A squared divided by A is A. B squared divided by B is B. And over here, everything cancels out, so that leaves a 1 behind. Okay, for this next problem, this is a situation called a difference of squares, but we can still solve it the same way we learned in class. So it can help to put a placeholder 0x in there, right? Because now we can apply our area model. Okay, so the two missing boxes have to add up to 0x, and they have to multiply to 4x squared times negative 9 is negative 36x squared. Okay, so if two things add up to 0, they must be the positive and negative versions of the same value. Okay, and then to get to 36, what number times itself is 36? It's 6. So the missing terms must be 6x and negative 6x. Right, these add to 0x, and they multiply to negative 36x squared. Okay, so now we factor by GCF every row and column. 4x squared and negative 6x have a 2x in common, and I use the positive because the closer box is positive. Then 6x and minus 9 have a positive 3 in common. 4x squared and 6x have a 2x in common, and negative 6x and negative 9 have a negative 3 in common. So my factors are 2x plus 3 and 2x minus 3. Okay, problem 4. So there's 4 terms here, but we can try to set it up the same way. Okay, so I got x squared and negative 8y, and then I can just put these in any order. Okay, so let's see what happens if we try factoring out. X squared plus 2xy has an x in common. Negative 4x and negative 8y have minus 4 in common. X squared and negative 4x have an x in common. And then 2xy and negative 8y have a 2y in common. Okay, so it appears we have an answer, but we need to check by distributing. So we have x times x is x squared, x times negative 4 is negative 4x, 2y times x is 2xy, and then 2y times negative 4 is negative 8y. Okay, so it does match exactly, so that must mean that our factorization was correct. Okay, so the danger with this situation is if when you try to factor with the area model, your answer sometimes doesn't work. So you need to verify by multiplying it out. Over on problem 9, we first want to factor by GCF. So all 3 terms have an x in them, so we can take that out. Okay, so again, our final answer, you don't want to forget about that, but if factorable, it will then look like this. Okay, so let's see what we can do. So again, we're factoring the new quadratic, not the original. Okay, so the 2 missing boxes must add up to the middle term of 16x, and they must multiply to the same product as this, which is 48x squared. Okay, so I'm going to list all the different ways I can multiply to 48x squared. It will be 1x times 48x, 2x times 24x, 3x times 16x, 4x times 12x, 5 does not go into 48, 6x times 8x. 7 does not go into 48, and then now I'm at 8, so I'm repeating. And I can also have the negative versions of all of these, because the negative times a negative is also a positive. Okay, so I'm looking for which of these pairs, which multiplies to positive 48x squared, also adds to 16x. So these add to 49x, add to 26x, add to 19x, add to 12x. Sorry, 16x. All right, so this pair, 4x and 12x, they add up to 16x, and they also multiply to 48x squared. Okay, so those go in the two missing boxes in any order. And lastly, we want to factor by GCF. Right, so 16x squared, factor out the 12x, 16x squared and 12x, those have a 4x in common. Negative 4x and 3. So nothing really goes into both of those, so you can always factor out a 1, but in this case a negative 1 because it's a negative box that's closest. 16x squared and negative 4x, those have a 4x in common. And 12x and 3, those have a positive 3 in common. Okay, so one factor is 4x plus 3, the other factor is 4x minus 1. And then maybe something like problem 21. Okay, so again, always start by factoring by GCF, so it's got to go into all three. Coefficients first, 6, negative 2, and 14, those all have a 2 in them. X to the fourth, x squared, x to the third, those all have at least x to the second power. Then y to the fifth, y to the third, y to the fourth, those all have at least y to the third. Okay, so what's left over? 6 divided by 2 is 3, x to the fourth with x to the second taken out still has x to the second behind, y to the fifth with y to the third taken out still has y to the second power left behind. Okay, negative 2 divided by 2 is negative 1. X squared with the x squared taken out goes away, and y cubed with the y cubed taken out also disappears. So negative 2 divided by 2 is negative 1. Okay, then 14 divided by 2 is 7, positive 7. X cubed with an x squared taken out still has 1x left over, and y to the fourth with a y cubed taken out still has a single y left over.